Next question, we want to solve this system. In this system, you have two lines, x plus 3y equals to 11 and 3x plus y equals to 9. So you basically want to check to see if these two lines are intersecting or they're parallel to each other. What's the connection between these two lines? It means that if the system is consistent or inconsistent. But using intermediate algebra technique doesn't work here. We are in linear algebra class, so we want to form the augmented matrix. The augmented matrix here is given by 1, 3, and 11. 1 is the coefficient of x, 3 is the coefficient of y, and 11 is a constant term. Now let us move on to the second row. You're going to have 3, 1 times y equals to 9. Basically taken from the second equation, you have 3, 1, and 9. Remember that your goal is to convert this augmented matrix into reduced row echelon form, which is basically saying that, hey, the pivot on the first row must be 1 and everything below 1 must be 0. The pivot on the second row must be 1 and everything above 1 must be 0. Take a look. You have 1 as a pivot on the first row, but down here, you don't have a 0, you have a 3. So what are we going to do? We're going to apply row operations, elementary row operations to convert this matrix. You can interchange two rows. You can multiply one row by a non-zero constant. You can add a multiple of a row to another row. So what are we going to do? We're going to multiply the first row by -3 and add it to the second row. Take a look. Adding -3 times the first row to the second row gives us the following matrix. Let's take a look at the algebra. We're going to multiply the first row by -3, so -3, -9, -33, plus 3, 1, and 9 basically creates a new second row for you, which we write here, 0, -8, and -24. Now what you can do, you can basically divide the second row by -8. It creates a new second row for you, which is 0, 1, and 3. Now stop and compare your matrix with the matrix that you're trying to convert it to. You have a 1, down here you have a 0, you have a 1, on top of it you have a 3. You can stop at this point, or you can multiply the second row by -3 and add it to the first row and make it a little bit simpler. But it's not very difficult to see the system of linear equations at this point by 1 times x plus 3 times y equals to 11 and 0 times x plus 1 times y equals to 3. So basically, you already have a solution for your y. You're going to use back substitution to find your x. Or as I mentioned before, you can multiply the second row by -3 and add it to the first row to make your life much more easier. But back substitution also works here. If you plug in 3 into the first equation, your x becomes 2. So as you can see, this original system is consistent with one unique solution, x equals to 2 and y equals to